Hey Wiz, is there a way to know what comes out of any RAG application that we build is right or correct?
Well, it's really hard to say things like it's absolutely right, it's absolutely correct, it's absolutely true. That's pretty
Hmm.
difficult.
Okay. So there's no absolutes, but is there a way to know that changes that we make to the system, to our RAG application, makes the performance better or worse?
That we can know absolutely.
So you're saying there's a way to assess RAG systems?
Yeah, I think like a RAG assessment kind of makes sense.
A rag assessment, huh? Yeah, man. Let's show everybody how to do that today.
Let's do it.
All right, man. My name is Greg, and we are here to talk rag eval today. AI Makerspace, thanks for taking the time to join us. Everybody in our community, we'd love to hear you shout out in the chat where you're calling in from. Today, we're going to walk through a simple RAG system built with the latest and greatest from LangChain, their most recent stable release and most stable version ever. We're also going to outline how you can actually assess your RAG systems using the RAG assessment or RAGAS framework. Finally, we'll do some advanced retrieval. We'll just sort of pick one off the shelf that's built into LangChain and show how we can go about this improvement process. We are very excited to have the RAGAS co-founders and maintainers, Jitin and Shaul, joining us for the Q&A today. So definitely get your questions in the chat. Anything you're curious about RAGAS, we have the creators in the house today. And of course, we'll see Wiz, aka the LLM Wizard, and CTO at AI Makerspace back for demos real soon. So let's get into it, everybody. Today we're talking RAG evaluation, this black art that everybody is really focused on as they start to build, prototype, and deploy these systems to production in 2024. As we align ourselves to this session, we want to get out of this. What's up with this LangChain v0.1 that just came out? We want to understand how we can build a RAG system with the latest syntax and then also evaluate it. There's a lot of changes happening on the RAGAS side, just as on the LangChain side. Finally, we want to see how we can pick different tools, different ways to improve our system or application, and how we can then quantify that using evaluation. So first we'll go into LangChain, then we'll go into a high-level view of RAG and see exactly where the different LangChain components fit in. Finally, we're going to see what you all came here for today, the RAGAS metrics and how to implement the RAGAS framework. So we'll be building, we'll be evaluating, we'll be improving today, and the Q&A should be pretty dope. So LangChain v0.1.0. What's LangChain all about again? Well, it's all about enabling us to build LLM applications that leverage context, are so-called context aware, so we can connect to other sources of data. We can do lots of interesting prompt engineering. We can essentially do stuff in the context window that makes our applications more powerful. And also reasoning. This is the agentic behavior stuff. And look for another event from us soon that focuses more on reasoning. Today, we're focused on context, though. And we're doing that in the context of v0.1.0. The blog that they put this out with said the journey of 1,000 miles always starts with a single step. And that's kind of where LangChain sees themselves to be today. LangChain core has come together. LangChain community has come together. And they're officially going to be incrementing v0.1 to v0.2. If there are any breaking changes, they'll be incrementing this, and they'll continue to support v0.1 for a time every time this gets incremented. Of course, as bug fixes and new features come out, they're also going to be incrementing now in this third v0.1.x slot. So pay attention to how quickly the development goes from here, because I imagine there's a lot of great stuff on the horizon coming from LangChain. There was a lot of great stuff in the v0.1 release. And We're going to primarily focus on retrieval today and also on this sort of LangChain core that leverages LCEL, or the LangChain expression language. So in terms of retrieval, there's going to be a lot that you can check out and add after today's event that you can then go assess to see if it actually helps your pipelines. So definitely encourage you to check those things out in more detail after today. For production components, there's a lot that we hope to explore in future events as well. But starting from the ground up here, we want to kind of focus on this LangChain core. This is the LangChain expression language, and this is really a very easy, kind of elegant way to compose chains with syntax like this. This dovetails directly into deployments with LangServe, into operating in production environments, and monitoring and visibility tooling with LangSmith. So really, it kind of all starts from here and allows you to really do some industry-leading best practice stuff with these tools. Now, today, we're going to focus on a couple of the aspects of LangChain. We're going to take LangChain core functionality, and then we're also going to leverage models and prompts, as well as retrieval integrations from LangChain community. Chains, of course, are the fundamental abstraction in LangChain, and we will use those aspects to build our RAG system today. When we go and we assess, then we're going to take it to the next level with an advanced retrieval strategy. This is going to allow us to quantitatively show that we improved our RAG system. So, quick recap on RAG in general for everybody. The point of RAG is to really help avoid these hallucinations. This is the number one issue everybody's talking about: confident responses that are false. We want our systems, our applications to be faithful. And we'll see that we can actually evaluate this after we build out systems and instrument them with the latest evaluation tools. We want them to be faithful to the facts. We want them to be fact checkable. This idea of RAG is going and finding reference material, adding that reference material to the prompt, augmenting the prompt, and thus improving the answers that we generate. Visually, we can think of asking a question, converting that question to a vector, embedding representation, and then looking inside of our vector database, our vector store, the place where we store all of our data in vector format. We're looking for similar things, similar to the vector question we asked. We can find those similar things, and if we've set up a proper prompt template before we go into our LLM, something that says, for instance, use the provided context to answer the user's query. You may not answer the user's query unless you have context. If you don't know, say, I don't know. And then into this prompt, we inject these references. We augment this prompt. And then, of course, where does the prompt go? Well, it goes into the chat model, into our LLM. This gives us our answer and completes the RAG application input and output. So again, RAG is going to leverage models, prompts, and retrieval. In terms of models, we're going to use OpenAI models today. One note on syntax is that the chat style models we use generally leverage a system user assistant message syntax, and LangChain is going to tend to prefer this system human AI syntax instead, which personally I think is a little bit more straightforward. In terms of the prompt template, well, we already saw it. This is simply setting ourselves up for success so that we can inject those reference materials in and we can generate better answers. Now, it's important what these reference materials contain and how they're ordered, and that is going to be the focus of our evaluation. Of course, when we create a vector store, we're simply loading the docs, that's the document loader, splitting the text, that's the text splitter, creating embeddings, we use an embedding model, and storing the vectors in our vector store. Then we need to wrap a retriever around, and we're ready to rock and RAG. Our build today is going to leverage, as mentioned, OpenAI models. We're going to leverage the ADA embeddings model and OpenAI's GPT models. And the data we're going to use is actually, we're going to set up a RAG system that allows us to query the LangChain v0.1.0 blog. So we'll read in this data and we'll create a RAG based on this LangChain blog that we can ask, see if we missed anything that we might want to take away from this session that we could also learn about v0.1.0. So to set up our initial RAG system, we're going to send you over to Wiz to show us LangChain v0.1.0 RAG setup.
Hey, thank you, Greg. Yes. So today we're going to be looking at a very straightforward RAG pipeline. Basically, all we're going to see is how we get that context into our LLM to answer our questions. And then later on, we're going to think about how we might evaluate that. Now, the biggest changes between this and what we might have done before is the release of LangChain v0.1.0. So this is basically LangChain's, first real minor version. We're looking to see this idea of, splitting the core LangChain features out. And that's exactly what, Greg was just walking us through. Now, you'll see that we have mostly the same code that you're familiar with and used to. We can still use LCL as we always have. That's staying part of the core library. But we also have a lot of different ways we can add, bells and whistles or different features to our LangChain application or pipeline. So in this case, we'll start, of course, with our classic import or our dependency LangChain. But you notice we also have a specific package for OpenAI, for core, for the community LangChain, as well as LangChain Hub. And so all of these let us pick and choose whatever we like, really, from the LangChain package. This is huge, right? So one of the things that people oftentimes are worried about LangChain is there's a ton of extra kind of unnecessary things in there. Well, this is goes a long way to solving that problem, and it's awesome. So let's see first which version we're working with. So if you're watching this in the future, you can be sure. So we're on version 0.1.5. So we're already at 0.5. LangChain, they're hard at work over there. We're going to need to add our OpenAI API key since we are going to be leveraging OpenAI. Basically, this is a way that we can both use our LLM for evaluation, but also for generation and also for powering the application. We're just going to use this one LLM today for everything. When it comes to building our pipeline, it's very much so the case that, we have the same stuff that we always have. We need to create an index, and then we need to use an LLM to generate responses based on the retrieved context from that index. And we're going to get started, as we always do, with creating the index. Now, we can and will still use LCEL. LCEL is important. One of the things that we're going to show in this notebook is you don't have to use LCEL. They've implemented some abstractions in order to modify the base chains that you're used to importing to LCL format, so you get all the advantages. But we're still going to look at LCL today because it is an important piece of the LangChain puzzle. But first, we're going to start with our first difference, right? So we're going to load some data. And we're going to load this from the LangChain community package, where we're going to grab our document loader to get our web-based loader. Importantly, this is not part of core LangChain. This is a community package, and it works exactly the same as it used to, as it always has. Our web-based loader is going to let us load this web page, which we can do with loader.load. And then we can check out that we have our metadata, which is just for our web page. We're happy with that. Next, we need to do the second classic step of creating index. We have a document in this case. It's just one document, but we have it, and we need to convert it into several smaller documents, which we're going to do with the always fun recursive character text splitter. You'll notice that this has stayed part of core. So this is in just the LangChain base package. Hooray. We have a recursive character text splitter. We've chosen some very arbitrary chunk sizes and overlaps here, and then we can split those documents. This is less so focused on specific LangChain RAG and more on the evaluation. So we're just kind of choosing these values, to showcase what we're trying to showcase. You see that we've converted that one web page into 29 distinct documents. That's great. That's what we want to do with our splitting. Next, we're going to load the OpenAI embeddings model. Now, you'll notice that we're still using text embedding ADA 002. We don't need to use this embeddings model, and it looks like very soon we'll be able to use OpenAI's latest model once the tick token library updates. There's a PR that's ready, just waiting to be merged, which is going to let us be able to do that. But for now, until that change is implemented, we're going to stick with text ADA embedding 002. And this is like the classic embedding model, right? Nothing too fancy, just what we need. When it comes to our face vector store, what we need is to get that from LangChain community, but otherwise, this is exactly the same as it used to be, right? So there's no difference in the actual implementation of the vector store. It's just coming from the community channel. We'll pass in our split documents as well as our embedding model, and away we go. Next, we're going to create a retriever. This is the same as we've always done. Dot as retriever on our vector store. Now we can interact with it through that Retrieval API. We can test it to see it working. Why did they change to version 0.1.0? And we get some relevant documents to that query that mention the 0.1.0 release. Hooray. Now that we've got our retrieval pipeline set up, that's the R in RAG, we need to look at creating that AG. So what we're going to do is showcase a few different ways that we can create a prompt template. You can just pull it from the hub. So there are lots of different community created or LangChain created hubs. The idea is that you can just pull one that fits your task from the hub. But the one that we're showcasing is maybe not ideal, so we're going to go ahead and create our own. You can still do this process if you want to create your own. You don't have to use a one from the hub. And so we're just going to create this simple one, answer the question based only on the following context. If you cannot answer the question with context, please respond with I don't know. That's a classic. We pass in our context, we pass in our question, away we go. And you'll notice that this is exactly the same as it used to be. Let's go LangChain. Now we'll set up our basic QA chain. I've left a lot of comments here in the implementation of this LCEL chain in order to hopefully clarify exactly what's going on. But for now, we'll just leave it at we can create this chain using LCEL. And we want to pass out our context along with our response. This is important in order for us to be able to do those evaluations that we're hoping to do with RAGAS. So we do need to make sure that we pass out our context as well as our response. This is an important step, and we'll look at another way to implement this chain a little bit later, which is going to showcase a little bit more exactly what we can do to do this a little bit easier with still getting the advantages of LCEL. You'll notice we're just using GPT-4 Turbo. That's it, and there you go. Now we can test it out, and we can see, what are the major changes in v0.1.0. The major changes are information. Oh, it goes on. It gives a correct answer. That's great. And we have what is Lang graph. And basically, the response from the LLM is, I don't know, which is not necessarily satisfying. So we're going to see a way to improve our chain to get a better answer to that question. And the next step, now that we have this base chain, would be to evaluate it. But before we do that, let's hear from Greg about how we're going to evaluate it and what we're going to evaluate it with. And with that, I'll pass you back to Greg.
Thanks, Wiz. Yeah, so that was LangChain v0.1.0 RAG. Now let's talk RAG assessment. The RAGAS framework essentially wraps around a RAG system. If we think about what comes out in our answer, we can look at that. We can assess different pieces that helped generate that answer within the RAG system. And we can use that information to then decide on updates, on different things that we might try to add to either augment our retrieval or our generation. And we can continue the process of improvement by continually measuring. But what are we measuring? Well, this is where the RAG evaluation really gets particular. We have to make sure that we understand the core concepts of RAG eval. And in order to sort of do this in an automated way, we need 4 primary pieces of information. You're probably familiar with question, answer, input, output, and you may even be familiar with question, answer, context triples. What we need for eval is we need to also add a 4th component, the ground truth, sort of the correct or right answer, so to speak. Now, in practice, it's often not feasible to collect a comprehensive, robust ground truth data set. So again, what we can do, since we're not focused on absolutes here, is we can actually create a ground truth data set synthetically. And this is what we'll do today. We'll find the best model that we can, pull GPT-4 off the shelf, and we'll generate this set of information that will allow us to do evaluation. Okay, so we'll see how this works. It's pretty cool. And RAGAS has a new library for this. But in terms of actual evaluation, when we finally have this data set up, we need to look at 2 different components. The first component is retrieval. There are 2 metrics that focus on retrieval exclusively. One is called context precision, and context precision asks the question, how relevant is the context to the question? All right. Context recall, on the other hand, asks the question, is the retriever able to retrieve all of the relevant context relevant to the ground truth answer? On the generation side, we have 2 metrics as well. The first is answer relevancy, which asks the question, how relevant is the answer to our initial query? And finally, faithfulness tries to address the problem of hallucinations and asks, is the answer fact checkable from the context, or is this a hallucination? So the 4 primary metrics in the RAGAS framework are these 4, 2 for retrieval, 2 for generation. Let's dig in a little bit deeper to each one so that we really try to start grokking each metric individually, because they're slightly different but nuanced. Faithfulness is trying to measure this factual consistency. Let's look at an example. The question, where and when was Einstein born? Context. If this is the context, Albert Einstein, born 14 March 1879, was a German-born theoretical physicist, et cetera, et cetera. So a high faithfulness answer is something that says, well, he was born in Germany and he was born on 14 March 1879. Where a low faithfulness answer might get part of it right, but might hallucinate, right? We want to avoid these hallucinations with faithfulness. So we're looking at the number of claims that can be inferred from the given context over the total number of claims in the generated answer. To be 100% faithful to the facts, we want this to be the same number. Okay, so answer relevancy is trying to, of course, measure how relevant the answer is. Rather than considering factuality, how factual it is, what we're doing here is we're penalizing when the answer lacks completeness, or on the other side, when it contains redundant details. So for instance, where is France and what is its capital? A low relevance answer is like talking to somebody that's not paying attention to everything that you said. Oh, France is in Western Europe. It's like, yeah, okay, well, what about the other part of my question, right? You want it to be completely relevant. to the input, just like a good conversationalist's answer would be. Very relevant, right? Okay, so context precision, as we get into the retrieval metrics, we're thinking about, in this case, a way that we can evaluate whether all of the ground truth relevant items are present in the context and how well ranked they are in order. So what we're looking for is we want all the most relevant chunks that we return from our vector database to appear in the top reference ranks. Okay, we want lots of good stuff ranked at the top. That's what we want. And so we're really looking for everything that's relevant to the question to then be returned in our context and to be order ranked by relevancy. Makes sense, you know, just the way we would want to do it if we were writing a book report or something. Finally, context recall is, again, kind of doing this same thing that we talked about before. We want to make sure we're paying attention to everything that's relevant. We want to make sure that we're addressing everything that's asked. So if the question here, where is France and what is its capital? Once again, if we have a ground truth answer already, the key here is we're actually leveraging ground truth as part of calculating this metric. France is in Western Europe and its capital is in Paris. A high context recall is addressing both of these, and within each sentence of the output addressing both of these, you can look sort of ground truth sentences that can be attributed to context over number of sentences in ground truth. And a low context recall is going to kind of be doing the same thing that we saw earlier. Well, France is in Western Europe, simple villages, Mediterranean beaches, country is renowned, sophisticated cuisine, on and on and on, but it doesn't address anything about Paris, which of course the ground truth does. So again, we can look at this sort of holistically here, and we can start to get a picture of, if we look at each of these metrics, we get some idea of how our system is performing overall. But that's, you know, generally kind of difficult to get a perfect picture of that. You know, these are the tools we have, and they work, as we mentioned, very well for directional improvements. Context precision is sort of conveying this sort of high-level quality idea, right? Not too much redundant info, but not too much left out. Context recall is measuring our ability to retrieve all of the necessary or relevant information. Faithfulness is trying to help us avoid hallucinations. And answer relevancy is sort of, am I to the point here? Am I very, very relevant to the question that was asked? Or am I kind of going off on a tangent here? And finally, RAGAS also has a few end-to-end metrics. We're just going to look at one of them today, just to give you an idea. And that one is called answer correctness. This is a great one for your bosses out there. You want to know if it's correct? Boom. How about we look at correctness, boss? So this is potentially a very powerful one to use for others, but beware, you know what's really going on, and directional improvements is really what we want to be focusing on. But we want to basically look at how the answer is related to the ground truth. Of course, if we have like a true ground truth data set, this is probably a very, very useful metric. If we have one that's generated by AI, we might want to be a little bit particular, a little bit more careful in looking at this metric and relying on it too much. But if we have this great alignment between ground truth and answer, we're doing a pretty good job, right? Let's see a quick example for this one. We're kind of looking at two different things. We're looking at that factual similarity, but we're also looking at semantic similarity. So, you know, again, you can use this Einstein example. if the ground truth was Einstein was born in 1879 in Germany, the high answer, correctness answer is exactly that. And then, of course, low answer correctness is you're getting something literally wrong. So there is overlap between all of these things, and it's important to sort of track that. But overall, the steps for doing RAGAS are to generate the question, answer, context, ground truth data. And there's an awesome new way to do this called synthetic test data generation that has recently been released by RAGAS. We'll show you how to get it done today. Run that eval, and then go ahead and try to improve your RAG pipeline. We're just going to take one simple retrieval improvement off the shelf from LangChain today. It's called the multi-query retriever. This is going to sort of generate many queries from our single query and then answer all of those and then return the relevant context from each of those questions into the prompt. So we're actually getting more information. But you can pick any retrievers off the shelf, and you can then go back. You can look, did my metrics go up? Did they go down? What's happening as I add more data or more different retrieval advanced methods to my system? And in this way, we can see how we can combine RAGAS with RAG improvement, as Wiz will go ahead and show us right now.
Oh, yeah, Greg. Can't wait. Thank you. So, RAGAS, this is the thing we're here to talk about, right? It's a amazing library that does a lot of cool, powerful things. But the thing that is, most important is that it allows us to have some insight into changes we make in terms of the directional impact they have, right? So while we might not be able to say, these answers are definitely true, as Greg was expressing, we can say, it appears as though these answers are truer than the ones we had before, which is awesome. So let's look at how we can do this. First of all, in order to actually do, a evaluation on all of the metrics, we need to have two important things. One, we need to have questions. So these are questions that are potentially relevant to our data. In fact, they should be relevant to our data if we're trying to assess our retrieval pipeline as well as our generations. And also some ground truths, right? As Greg was mentioning, we are going to use synthetically created ground truths. So it might be more performant to use, let's say, human labeled ground truths. But for now, we can let the LLM handle this. I'll just zoom in just a little bit here. And the idea is that we're going to leverage RAGAS's new synthetic test data generation, which is very easy to use, much better than what the process we had to do before, which was kind of do this process manually. We're going to go ahead and use this to create our test data set. Now, it's important to keep in mind that this does use GPT-3.5 Turbo 16K as the base model, and it also includes GPT-4 as the critic. So we want to make sure we're not evaluating or creating too much data, or if we are, that we're staying very cognizant of the costs. So the first thing we're going to do is just create a separate data set or separate document pile that we're going to pull from. We're doing this to mitigate the potential that we're just asking the same LLM the same questions with the same context, which might, unfairly benefit the more simple method. So we're just going to create some new chunks with size 1,000, overlap 200. We're going to have 24 docs, so about the same, 29, 24. And then we're going to use the test set generator. It really is as easy as test set generator with OpenAI. That's what we're using for our LLM. And then we're going to generate with LangChain docs. You'll notice this is specifically integrated with LangChain. There's also a version for Llama Index. And all we need to do is pass in our documents, the size that we like of our test set, and then the distributions. Now, this distributions is quite interesting. Basically, this is going to create us questions at these ratios from these subcategories. So the idea is that this is going to be able to test our system on a variety of potentially different, tests, right? So we have simple, which is, as you might think, very simple. And we have, this reasoning, which is going to require some more complex reasoning that might, tax our LLM a little harder. then we have this multi-context, which is going to require multiple contexts. So our LLM is going to have to pick up a bunch of them in order to be very good at this particular kind of task. And the reason this is important is that not only do we get kind of an aggregate directional indication of how our system is improving, but we can also see how it's improving across specific subcategories of application. Very cool, very awesome. Thanks to the RAGAS team for putting this in. It's we love this, and it makes our job very much a lot easier. So that's great. We look at an example of the test data. We have our question, we have some contexts, and then we have our ground truth response, as well as our evaluation type, which is in this case simple. In terms of generating responses with the RAG pipeline, it's pretty straightforward. There is an integration that exists between LangChain and RAGAS. It's currently being worked on to be brought up to speed. But for now, we're just going to kind of do this manually. So what we're going to do is we're going to take our test set. We're going to look and see we've got our questions, context, ground truths, as well as our evolution type, or our this is our distribution that we talked about earlier. And then we're going to grab a list of questions and ground truths. We're going to ask those questions to our RAG pipeline, and we're going to collect the answers, and we're going to collect the contexts, and then we're going to create a Hugging Face data set from those collected responses, along with those test questions and our test ground truths. We can see that each of the rows in our data set has a question with our RAG pipeline's answer, our RAG pipeline's contexts, as well as the ground truth for that response. Now that we have this data set, we're good to go, and we can go ahead and we can start evaluating. Now, Greg's talked about these metrics in depth. The code and the methodology can be found in the documentation from RAGAS, which is very good. These are the ones we're caring about today: faithfulness, answer relevancy, context precision, context recall, and answer correctness. And you can see it's as simple as importing them, and then putting them into a list, so that when we call the evaluate, we're going to pass in our response data set, which is this data set we created above that has these rows for every question, and then our metrics, which we've just set above. And that's all we have to do. Now, the test set generation is awesome and very useful. Another change that RAGAS made recently is that they've made their evaluation async. So this is a much faster process than it used to be. As you can see, this was around 42 seconds, which is much better than the times that we used to see. So thanks, RAGAS team, for making this change. We can get our results here. We have our faithfulness, our answer relevancy, our context recall, our context precision, and our answer correctness. You can see that it does all right. But again, these numbers in a vacuum aren't really indicative of what's happening. It's like we want these numbers to be high, but we're more interested in seeing if changes we make to our system make those numbers higher. So let's look at another awesome part of RAGAS before we move on to making a change and seeing how it goes. Which is we have the ability to look at these scores at a per question level in the Pandas data frame. So you can see that we have all of our scores, and they're given to us in this data frame. This is huge, especially because we can map these questions back to those evolution types, and we can see how our model performs on different subsets of those elements in that distribution. So now we're going to just make a simple change. We're going to use the multi-query retriever. This is stock from the LangChain documentation. We're going to use this as an advanced retriever, so this should retrieve more relevant context for us. That's the hope anyway. We'll have our retriever and our primary QA LLM. So we're using the same retriever base and the same LLM base that we were using before, and we're just wrapping it in this multi-query retriever. Now, before we used LCEL to create our chain, but now we'll showcase the abstraction, which is going to implement a very similar chain in LCEL, but we don't have to actually write out all that LCEL. So we're going to first create our stuff documents chain, which is going to be our prompt. We're using the same prompt that we used before, so we're not changing the prompt at all. And then we're going to create retrieval chain, which is going to do exactly what we did before in LCEL, but we don't have to write all that LCEL. So if you're looking for an easier abstracted method, here you go. You'll notice we call it in basically the same way. And then we are also looking at this answer. The answer is basically, the response.content from before. And then, we can see this is a good answer, makes sense to me. But we also have a better answer for this what is LangGraph question. So this heartens me, right? I'm feeling better. Like maybe this will be a better system. And before, you might have to just look at it and be like, yeah, it feels better. But now with RAGAS, we can go ahead and just evaluate. We're going to do the same process we did before by cycling through each of the questions in our test set and then getting responses and context for them. And then we're going to evaluate across the same metrics. You'll notice that our metrics have definitely changed. So let's look at a little bit more closely how they've changed. So it looks like we've gotten better at our faithfulness metric. We've gotten significantly better at answer relevancy, which is nice. We've gotten a little bit better at context recall. We've taken some small hits, a small hit on context precision, and a fairly robust hit on answer correctness. So it's good to know that this is going to improve kind of what we hoped it would improve. And now we are left to tinker to figure out how would we improve this so our answer correctness doesn't get impacted by this change. But at least we know in what ways, how, and we're able to now more intelligently reason about how to improve our RAG systems thanks to RAGAS, right? And each of these metrics correspond to specific parts of our RAGAS application. And so it is a great tool to figure out how to improve these systems by providing those directional changes. With that, I'm going to kick it back to Greg to close us out and lead us into our Q&A.
Thanks, Wiz. Yeah, that was totally awesome, man. It's great to see that we can improve our RAG systems, not just sort of by thinking about, I think that's better. LangGraph question got answered better, but actually we can go and we can show our bosses, our investors, anybody that might be out there listening, hey, look, we have a more faithful system. Check it out. Went from base model to multi-query retriever and improved our generations. Of course, as developers, you want to keep in mind exactly what the limitations of each of these things are. But for all of those folks out there that aren't down in the weeds with us, if they really want an answer, here's an answer. And so it's awesome that we can go and take just things off the shelf that we're trying to qualitatively analyze before and directionally improve our systems by instrumenting them with RAGAS and measuring before and after small iterations to our application. So today we saw LangChain v0.1.0 to build RAG, and then we actually did RAG on the LangChain v0.1.0 blog. Expect stable releases from here. It's more production ready than ever. And you can not just measure faithfulness, you can measure different generation metrics, different retrieval metrics, even different end-to-end metrics. And big shout out to everybody today that supported our event. Shout out to LangChain, shout out to RAGAS, and shout out to everybody joining us live on YouTube. With that, it's time for Q&A, and I'd like to welcome Wiz back to the stage, as well as Jitin and Shaul from RAGAS, co-founders and maintainers. If you have questions for us, please scan the QR code, and we'll get to as many as we can. Guys, welcome. Let's jump right in.
Hey, guys.
Hey.
What's up?
All right. Let's see. I'll go ahead and toss this one up to Jitin and Shaul. What's the difference between memorization and hallucination in RAG systems? How can developers prevent hallucinated content while keeping the text rich?
Yeah. You want to go for it, Jitin?
I know. I didn't actually understand what you actually mean by memorization.
Yeah.
Ooh, yeah, okay. You want to take a crack at this, Shaul?
Yeah, I mean, what is the difference between memorization and hallucination RAG systems? the line between memorization and hallucination, I don't know where to draw that particular line. It's something seems like seems like the what it meant is the usage of internal knowledge versus, there are situations in RAG when knowledge is a continually evolving thing, right? So maybe the LLM thing that a person is still alive, but the person died yesterday or something. Now if that particular thing is read using Wikipedia or something, there will be a contrasting knowledge between the LLM and what the ground truth Wikipedia says. Now that can be hard to overcome because the LLM still believes something else. So I think it's a hard to crack problem, and I hope there will be many future works on it. But how can we prevent such hallucination? The thing is, what we require is when using LLMs to build RAG, we can align LLMs so that LLMs answer only from the given grounded text data and not from the internal knowledge. So, or there must be high preference to the grounded text data compared to what is there in the LLM's internal knowledge. So that can be one of the solutions.
Yeah, definitely. Wiz, any thoughts on memorization versus hallucination before we move on here?
I think the answer to the question was already provided.
What is the
Basically,
difference, really? I mean, yeah.
When it comes to the memorization versus hallucination, I think the most important thing is memorization is you could maybe frame it as a slightly less negative form of a hallucination because it's likely to be closer to whatever the training data was. But in terms of RAG application, both bad. We want it to really take into account that context and stick to it.
Okay, we've got a question from Jan Boers. I'm curious if you already have experience with smart context-aware chunking. Can we expect significant improvements of RAG results using smart chunking? What do you think, Jitin? Is this something that we can expect improvements in?
Yeah, so one thing that we see when we building like RAG systems is that how you're formatting the data is like where most of the problems are. Like if you take some time to clean up the data and like to format the data, that actually makes it easier for your RAG. The performance diff is like really great because like models right now, if you're using a very stable model, if you provide with the correct context, the model will be able to use the information in the context to get it. So all these tips and tricks to optimize about, even like Chris was using the multi context method, right? It's also another trick to make sure that you get different context from different perspectives into the final answer. So all these different types of tricks can be used, and this is actually why we started this also. We wanted to like evaluate all the different like tricks that are there out there and try to see which works best, because it can be like different on your domain. So yeah, smart chunking is smart.
Yeah, yeah. So you're saying that like it actually matters what data you put into these systems just because they're LLMs, it doesn't solve the problem for you?
Yeah, that actually like matters a lot more because what goes in comes out. So that's important that you format your data.
That's right. The data-centric paradigm has not gone anywhere, people. You heard it here first. Garbage in, garbage out. So Matt Parker asks, maybe I'll send this one over to Shaul. Can you compare TrueLens and RAGAS? This is the first I've heard of TrueLens. Maybe if other people haven't, maybe you can tell us a little bit about what they're doing and what you're doing and the overlap you see.
Sure. TrueLens has been around for a while for evaluating ML applications, and they are also doing LLM applications. So RAGAS currently is mostly focused on RAGs, as in we wanted to crack the application that most people care about, that is RAGs, and so we are mostly doing things that can help people to evaluate and improve their RAG. So we are not building any UI. We are largely providing for the integrations part. We are largely interested in providing integrations to players like LangSmith, so that people can trace and see their UI rather than building a UI on top of RAGAS. So RAGAS mainly offers metrics and features like as you have seen synthetic text data generation, to help you evaluate your RAGs. I don't think TrueLens has a synthetic data generation feature, which is something that most of our developers really liked, because it has saved a ton of their time, because nobody really wants to go and label hundreds of documents. It's a boring job, right? So we are trying to double down on these points that we have seen that developers really like, and we are trying to stay true to the open source community as well.
Ooh, nice. Okay, very cool. Very cool. Rad asks, I'll send this one over to you, Wiz. Can you combine multiple query retriever with conversational retrieval chain?
Sure. Yeah. Basically, LangChain works in a way where you can combine any retriever inside of any chain, right? So a retriever is going to be some kind of slot that we need to fill with something. So if you want to use a more complex retrieval process or combine many different retrievers in an ensemble, you can do that with basically any chain. Basically, that conversational retrieval chain is looking for a retriever, and so as long as it can be accessed through the Retrieval API, it's going to work fine. I would add, though, conversational retrieval chain. You'll want to use the 0.1.0 version, which is been implemented with LCEL, but other than that, you're good to go.
Okay. And sort of back to this idea of sort of smart chunking, smart hierarchy of data. Is there sort of like, we often talk in our classes about this sort of black art of chunking. Everybody's like, well, what's the chunk size I should use? What's the chunk size? So Sujit asks, and maybe I'll send this one over to you, Jitin. I know the chunk size matters. Are there like guidelines for chunking that you guys are aware of or that you recommend when people are building RAG systems?
Yeah, so I don't have like a very good guideline. Maybe Shahul can take back it up. But one thing that I've like seen like personally from experience is like, so A, do the evaluations, but then B, like also making sure that you combine like multiple, like, so you basically you create a hierarchy system where you have like different chunks, then you summarize the different like concepts, like define the summarize the different chunks so that even like all the bare like core ideas are there in a hierarchy. That actually has been like very like helpful. So yeah, so exactly like chunking size, I haven't seen it in the like matrices as such, but all the recursive like summarization that has helped, and I think llama index has like a few retrievers right there. But Shahul, what do you think?
Yeah, just adding some more points into it. I think there is no one size fit chunk size that fits all type of documents and all type of text data. So it's a relative thing that should either you can. So there are two ways to handle this problem. Either you can, the general rule of thumb is to ensure that enough context, the context makes sense even without any as an individual as an individual chunk. It should make if it should make some sense if you read it, if a person read it. So how to achieve this? You can achieve this either using writing a set of heuristics, or let's say it can be something like, okay, determine the document type or something, and chunk it using that. And I think from moving from heuristics to where we are going, I think we might even see very smaller models that are capable of chunking, determining the chunk boundaries smartly, so that you don't really have to rely on the heuristics. It's more a generalizable way of doing it. So I think that's where we are going in the future of chunking, and hopefully the problem gets solved like that.
Yeah. I really like this idea of making sure each individual chunk makes sense before sort of moving up a level and thinking about, okay, what's the exact, hierarchical parent document, like whatever it is that you're doing, each chunk should make sense. And that's going to be dependent on data. Yeah, I really like that. And okay, so let's go ahead and sort of related to that, I want to go to this embedding model question in the Slido from Ron. It's similar in sort of relation to this chunking idea. I mean, people always want the answer, so what chunk size? Here, Ron asks, which embedding models should I be using when I develop a system? Any emergent models or techniques that I can see significant improvements with? Maybe Shaul, if you want to continue here.
Sure. Again, there is no one fit size for this answer. The thing is that again, it depends on a lot of factors. So if you don't want to really, use again, first, question will be open source or closed source. You have like a lot of open source players, even revealing OpenAI with their open source models. Like I think recently, by Alibaba Group released their M3 embedding, which is like awesome. It's like most powerful open source embeddings which we have ever seen, even revealing OpenAI's ADA embeddings, right? So it's a set of questions that you have to answer. If you want to go for easy way of building a baseline RAG, of course, OpenAI's embedding is good place to start. You don't have to worry about anything else. Then you can iteratively improve it. That's where also RAGAS comes in. Let's say you have an abundance of embeddings to choose from, right? So now you want a way to compare it. So use RAGAS. You can just compare all these different embeddings, choose the one that fits you, and you're done.
There it is. There it is. Just closing up this topic on chunks and embedding models. Wiz, I wonder, why did you choose Ada? Why did you choose, what is it, 750 overlap? Any particular reason?
Zero thought put into those decisions. We used Ada because it's the best OpenAI model that's currently implemented, and we used 750 because we did. Basically, we wanted to show that those naive settings are worse than a more considerate or a more mindful approach. And so to do that, we just kind of selected them. I think the thing I really want to echo that we've heard so far is when we're thinking about our index or we're thinking about our vector store, we really want to be able to represent individual like quanta of information. And so the closer we can get to that, the better it will be. And then we can add that hierarchy on top. And I think what was said about using models to determine that at some point is definitely a future we can imagine we'll be living in soon.
Yeah. And I think, again, we go back to this data-centric idea. It's easy to get the RAG system set up and to get instrumented with a RAGAS, but like you're going to get the improvements, you're going to get the thing really doing what you need it to do for your users by doing the hard, kind of boring data work, data engineering, data science on the front end that really you just can't outsource to AI, and you just have to kind of deal with yourself. Okay, one more sort of like what's the answer question. I want to maybe send this one to Jitin. If somebody's picking up RAGAS and they build a RAG system and they're like, okay, well, which RAGAS metric should I use? Which one should I look at, right? What would you say? Is there a starting point? Is there a sequence that you'd look at? Or it's the jury's not out yet on this?
Yeah, so we started off with the basic things, right? Like figure out what the like different components are, the generator part and the trivial component, and then just like for the first one, just try out like with all of the stuff. Like basically, like once you know which figuring out which component work, how, like what the state of which all these components are, gives you like idea of, okay, where can I make an improvement with like as fast as possible. If your generator is bad, maybe try out a few other LLMs, or maybe if your retriever is bad, then figure out, okay, in the retriever part, what is actually happening. Is it context relevancy? Is it the recall that's bad? And like that is the way. So starting off, try out all the metrics that you have, and then for the ones that are the worst, and like after you understand like what the metrics are, you will get an idea of how you could, like what are the stuff you can actually try out to improve it. And if it's like, try out the easiest part, like cross out the low hanging fruits first, and that is how you would like over time like progressively like improve it. Like I said, it's not the absolute values that matter, it's like the trends that matter, right? So you guys did a good job in explaining that. So make sure like you go for the easiest things that you can patch up fast and keep that trend in the upward direction.
Yeah, I love it. If you're getting low retrieval metrics, maybe pay attention to some retriever stuff. If you're getting low generation metrics, maybe try a different model. It's like, it's so simple when we can break it down like this. And, just a shout out to everybody out. And Manny, just shouting out to Manny. That was kind of an attempt to answer one of your many questions today. We'll see if we can get some more on LinkedIn. But I think this idea of like getting your system instrumented so you can start to look at and chunk up different pieces of it and try to improve them. There's a lot of content that needs to be made on this. These guys are open source first, open source forward. We'd love to see some folks in the community start to put some guides together for how to actually break down and use RAGAS in sophisticated ways. So last question, guys. We're at time here, but what's next for RAGAS in 2024? Maybe if either of you want to go ahead and take this, go ahead and take it. Let us know what to expect from you guys heading forward this year.
Yeah. Shahul, you want to take this?
Yeah, it's a tricky question. So you wanna go where the community takes us. So yeah, doubling down on things like synthetic data generation. There are a lot of interest there. There are a lot of interest in expanding RAGAS to other LLM tasks as well. So yeah, there are all these interesting directions to take. Hopefully, we'll get more signals from the community on which path so to take. I mean, we do have a lot of directions, a lot of feature requests coming in, so we have to just take that decision and move on the way. But yeah, as of now, the synthetic test generation is something that gets a lot of interest. We want to make it very stable, very useful, make sure that we push the limits of the closed source models and plus frameworks analogy to build a great test data point that's very easy and easy to use. Yeah.
Love it.
Yeah.
Anything to add, Jitin?
Yeah, like honestly, like so right now we have a good base, right? Now we're like very curious what we can do, like evaluation driven development. What are the extremes of that? So we're like curious to see like what the community comes up with, what like you guys can will come up with. So yeah, really excited for that. So.
Yeah. Let's see what everybody builds, ships, and shares out there and contributes. Well, thanks so much, Jitin. Thanks, Shaul. Thanks, Wiz. We'll go ahead and close it out for today. And thanks, everybody, for joining us. Next week, you can continue learning with us. We're talking alignment with reinforcement learning with AI feedback. If you haven't yet, please like and subscribe on YouTube. And if you haven't yet, but you like the vibe today, think about joining our community on Discord, where we're always getting together and teaching and learning. You can check out the community calendar directly if you're not a Discord user to see what's happening this week and in upcoming weeks. And finally, if you're ready to really accelerate LLM application development in your career or for your company, we have a brand new AI engineering bootcamp that's going to cover everything you need to prompt engineer, fine tune, build RAG systems, deploy them and operate them in production using many of the tools we touched on today, but also many more. You can check out the syllabus and also download the detailed schedule for more information. And then finally, any feedback from today's event, we'll drop a feedback form in the chat. I just want to shout out Jonathan Hodges as well. We will get back to your question, and we will share all the questions today with the RAGAS guys to see if we can get follow-ups for everybody that joined us and asked great questions today. So until next time, and as always, keep building, shipping, and sharing. And we and the RAGAS guys will definitely keep doing the same. Thanks, everybody. See you next time.